If you were in one of my periods today, of the two that I taught this lesson, you experienced a train wreck about halfway through the hour where we got stuck in a rut and then could never really get the train back on the tracks. This video is designed to clear up those issues and hopefully give us a second chance at an organized way to attack and solve these problems. If you were in the other period, you already heard this story and things went well, but you can use this video to remind you of the things that we talked about in class. So let me see if I can make an attempt at clearing things up, talking about what went wrong, and then showing you what we should have done. So both periods started innocently enough. We watched a couple of videos where we were taught that there could be no solution for a triangle. In other words, a triangle might not exist. Or in what we call the ambiguous case, there might be two triangles that meet the requirements of the problem. And then when I switched over this chart, that's where things started to fall off the rails. So this chart tries to organize all the things that she talked about in the video, but it does so in a very confusing way, especially if you're not careful about how you label the given information. And what we found is when we get to the problems, they start changing the letters up. They put B in the wrong place, they let you know what C is, and these charts don't even have C. In general, what the chart is trying to tell us is that when you are less than 90 for your given angle, you might have no solution. When you are greater than 90, greater than or equal to 90, you might have no solution. Or you might have one solution, which are these guys. Or you might have the ambiguous case, which is this last one, which is two solutions. And there's all these different calculations, all these different inequalities you need to keep track of, and it's like following a treasure map to figure out how to solve the problem, especially when the letters are all mixed up, because some of the problems have letter C, some of them had letter B, and that's where I ran into trouble and basically confused myself. Let's be honest, you were all there, you witnessed it. And it went downhill from there. So what I'm recommending is that we not deal with this particular chart, and let's make our own list of cases so that it's easy to follow and so that we can do the same thing on every problem. That's what people really want to know. They want to know, how in the world do we attack these problems? And that's what I'm going to try and clear up now. So I want to start by drawing one triangle that we'll use every time. And for each of these problems, we're going to be given an angle, and I always want that angle to be placed down here. We're going to be given an opposite side, and I always want that opposite side to be placed over here. And we're going to be given an adjacent side, and I always want that adjacent side to be labeled here. So here's our angle, here's our opposite side, and here's our adjacent side. In these problems, you're not given a picture, so we're going to use this picture to get us started, keeping in mind that we don't know for sure where that opposite side is going to fall, right? Depending on how long it is, it's going to be in different places. Now, we don't usually do math with these little words or abbreviations. We usually do math with variables. And so I'm going to use the same set of variables for every problem, but I don't want to confuse my variables with the ones that may or may not be in the problem. So I'm going to stay away from A, B, and C altogether. Instead, my angle, I'm always going to call capital D. That means that my opposite side is always going to be called D, and because my last name starts with M, my adjacent side is always going to be lowercase m. Now, what that means is if we're ever asked to solve the triangle, if that's lowercase m, this is capital M, and then the other sides, you can pick your letter. I'll just stick with C and C. Let me erase that one real quick. The capital C for the angle and lowercase c for the side. But those guys we are not going to be using right now. I'm focusing on these green letters. Don't worry about the yellow ones yet. So when you attack the problems, you should always begin by saying, hey, what is my angle? And we'll call that capital D. What is my opposite side? We'll call that lowercase d. And what is my adjacent side? We'll call that lowercase m. We always start with those. And once you have that down, your problems basically fall into cases. And I'm going to have more cases than the chart had. So I'm going to start with case 1. And we'll do that on this slide, and then I'll put the other cases on the next slide. So case 1 is when I have an acute angle, so D is less than 90, and lowercase d is smaller than side M. That's my case 1. Now here's the problem. There are 3 subcases that go along with this. Once you know that you have D is less than 90 and little d is less than M, you have to compute the height, which for us would be M times sine of D. So this is the height, right? I'm just going to put that in parentheses. You compute this value, and then your subcases are based on that. So subcase 1, I'll call 1A. Case 1A is my D is less than M sine 90, or M sine D, excuse me. If I'm less than the height, if D is less than the height, there is no solution. Case 2 would be that I'm equal to that height. So 1B, that D equals M sine D, capital D. If that's the case, I have one solution. And then the third case for case 1, I know that's confusing, but 1C we'll call it, is when my side is bigger than the height. And that's the ambiguous case from our chart. That means we have 2 solutions. So unfortunately, you have to do the whole problem twice. Okay. So case 1 has 3 subcases. There could be no solution, there could be 1 solution, or there could be 2 solutions. And this is the only case where you have to figure out that height, which is M sine D. And again, that came from the video that we watched in class. That part was done well. Okay, so case 1, please take time to jot this down in your notes, and then we're going to go over the other 3 cases on the next slide. They don't take up near as much space. Okay, so case 2 occurs when we still have an acute angle, so D is less than 90 degrees, and side D is greater than or equal to M. The last case, D was less than M. This case, side D is greater than or equal to M. If that's the situation, there is only one solution, and you just do the problem the way we did with the law of sines to get your one solution. So you solve the triangle. There's only one triangle that will fit those characteristics. Case 1 and case 2 together make up all of the acute angle situations. Case 3 is when we are greater than or equal to 90. So the obtuse and right angles. You could be greater than or equal to 90 degrees and D is less than or equal to M. If D equals M or it's less than M, then it turns out there's no triangle that fits that category, that fits that given information. So this is a no solution. And I must have bumped something. Oh, nope, it's moving. Okay, so when the angle is obtuse, but the side D, the opposite side, is less than the adjacent side, there is no solution. And then finally, case 4, when we have an angle greater than or equal to 90 and D is greater than M, then there's going to be one triangle that fits that scenario. So that's one solution. Okay, so we went over case 1, which had a lot of subcategories, but these cases are all pretty straightforward. Either there's one solution, no solution, or one solution for these. If you have these 4 cases written out while you're working on these problems, things are going to go a lot more smoothly. And I'm going to run through some examples now, and we'll do them the right way, and we'll run them through these cases to find out how to get the solutions. And the solutions will work, and hopefully we'll avoid the confusion that we had in class. The first problems that you're going to be asked to tackle ask you to determine the number of possible solutions for each triangle. So you're given some information about a triangle, and you're basically going to answer 1, 2, or none. 0, 1, or 2 for these problems. Those are the only possibilities. There's either no solutions, one solution, or 2 solutions. And for every problem, I recommend that you attack it in this way. Start by listing the information that you're given in terms that we've been discussing in the video. So angle D, capital D, the opposite side, lowercase d, and the adjacent side m. And we get that here from the given information. So the angle that they give me, they called it A, it's 113 degrees. I'm going to transform that into angle D, and now I have 113 degrees. The side that's opposite capital A is letter A, so that's going to be my lowercase d of 15. And then the other side is the adjacent side. For me, that's letter M, so I'm going to put an 8 here. Once you have this information, you start working your way through the cases. So I know that D is 113. D is greater than 90, right? So I'm either case 3 or case 4. Then I look at D and M. And based on this information, D is greater than M. So those two things put together, that is case 4. Oh, I didn't write case very well. That is case 4, and that means that there's one solution. And that's the answer for me for this problem. It says determine the number of solutions. The answer is 1. One solution. Pretty straightforward. Okay, now let's tackle this one and see if we can make sense of this thing based on our new strategy. Again, the first thing I recommend you do is assign capital D, lowercase d, and lowercase m, because that's what our cases are written out as in our notes. For us, D is 44, A, which is across from, B is across from angle B, so this is D is 12, and M is 23. Remember, capital D and lowercase d have to be across from each other, so that's these two. Okay, so let's start writing down what we have. We have an acute angle. D is less than or equal to 90. So that's definitely acute. And 12 is less than 23, so lowercase d is less than m. That happens to be case 1. All right? So this is case 1, and now we have to figure out which subcase it is. And for that, I need to compute that height. So we have to compute m times sine of d. So for me, that would be 23 times sine of 44. And we've already computed that here, so let me just write down what I came up with. For me, that came up with approximately 15.9. So there's my calculation for the height, and my 12 is less than that. My D is less than 15.9. That means this is case 1A, and we said the answer for 1A is no solution. So how many are there? There are 0 solutions. Okay. So our answer for that problem would be 0. That's how you should probably address these, so that you avoid the confusion with the letters, so that you don't run into the issues that I ran into in class earlier today. Okay, now let's talk about solving triangles using this method. And I'm actually going to pick out some homework problems to do for these. So if you're watching the video, you get free answers. So I want to start with number 18 here. Notice that the instructions say to find all solutions for each triangle. That means we need to list the missing information. So we're given 2 sides and 1 angle, and our job will be to find the missing angle, or missing 2 angles and the 1 missing side. Okay, and I'm going to focus on number 18 here. So we're going to start out the same way we did before, so we can run this through the cases and find out how many solutions are there. And if there is 1 solution, we'll find that. And if there's 2 solutions, we have to do both of them. Okay, so I'm going to start by labeling my information the way I did in the other examples. Angle is going to be 150, so my angle D is 150. The side opposite that will be the 6, and then the adjacent side M will be 8. And now I want to look at my cases. So D is bigger than 90, so it's either case 3 or case 4. And lowercase d is less than m. And when I look at my cases, that is case 3, and case 3 means we don't have any more work to do. There's no solution for this triangle, so I'm going to put none because that's what they say to do up here. So for number 18, we went through, looked at what we were given, figured out which situation it was. We are obtuse, but D is less than M. The opposite side is less than the adjacent side, and that can't exist, so there's no solution. And that's it for number 18. We are done with this sucker. All right? We're going to move on to a new slide, and we'll attack number 19. On number 19, the objective is the same. So remember, we're not doing 18 here. I'm just going to get that out of the way. We are supposed to find all solutions for the triangles. So if the solutions exist, we'll find all the missing parts. If they don't exist, we'll put none again like we did on the last one. And you know how I'm going to start this. I'm going to start by listing my information. So my angle is 58 degrees. My opposite side is 26, and my adjacent side is 29. I get my angle, my opposite side, my adjacent side, and I figure out what case I'm on. So this is D is less than 90, we're acute, and lowercase d is less than M, less than 29. And so that is case 1. We're smack dab in case 1 land. I have to figure out which subcase it is, though, and for that I need to compute the height. So I have to do 29 sine of 58 degrees, and I got to compute what that is. And so after typing that in on my calculator, I came up with about 24.6. D is greater than 24.6, right? 26 is greater than 24.6. So this is case 1C. This is 2 solutions, so we have to do double the work. Okay, so I'll probably do one of those on this screen, and then I'll do the other one on the other screen. Essentially, what we have to do is find the missing 2 angles and the missing side. So from the other screen that I drew with the letters on it, I need to find capital M, capital C, this is an angle M, angle C, and then lowercase c. These are the things I'm looking for. 2 missing angles and a missing side. All right, so to get that, we'll start with a law of sines, and we'll just get letter M real quick. And if we get M, we can use subtraction to get C. So I'm going to do sine of 58 over 26. That's my given D and D. And then I don't know angle M. Oops, I wrote sim. I do that in class a lot too, don't I? Sine of capital M over lowercase m, which is 29. And basically, we're going to do some cross multiplication, and we'll use inverse sine, and we'll find out that angle M is the result of this calculation. You do inverse sine on 29 times sine of 58. Oops, I wrote 88. Divided by sine of, divided by 26. And after we compute this on our calculator, we get the measure of angle M. So let's type that in and see what we get. I did the calculation, I took the inverse sine, and I came up with 71, I'm rounding it off to 71.1 degrees. And I'll use that measurement in a minute, so I want to remember that 71.1 because we'll use that to get the new angle M for the second case in a minute here. To get angle C, we just do, this is angle C, 180 minus 71.1 minus 58. And that'll tell us what angle C is, so we'll be done with that. Let me crank that out on my calculator. And when I did that, I got 50.9 degrees. So that's the second missing piece of information. 50.9, come on, man. And then to get side C, I'll have to do another law of sines. We'll do sine of 58 again over 26. I always start with my given information. And then I know that angle C is 50.9. I'm looking for lowercase side c. And the answer to that will be, when you do cross multiplication, you'll do 20 times sine of 50.9 divided by sine of 58. Oops, I wrote 88 again. Let's try 58. And we'll type that in our calculator and we'll get side C, and then we're half done with this problem. As I was typing this out, I realized I had a little typo here. This is 26 times sine of 50.9 divided by sine of 58. So let me retype this in and see what I get. And after I type that in, I come up with about 23.8 for the measurement of that side. And that is the last of the measurements. Okay, so unfortunately, all that work and all we've done is find one of the solutions. So one of the solutions is a triangle that has the angles 58, 71.1, and 50.9, and sides 26, 29, and 23.8. There is one other triangle that meets this list of information as well. And so we need to also talk about that one, and we'll do that on the next slide. So we're still working on number 19. We've already found one of the solutions, but now we need to find the other solution because we are using case 1C. We know that there's two solutions to this problem. Remember from the video that we watched, we learned that when you have the ambiguous case, your triangle might look like this, or this side might be drawn this way, and this might also be a solution, this triangle here. So the outside green triangle might be the solution, but this inside red triangle, it's not really inside, but this other red triangle might be the solution as well. We found the green one on the last slide, and this measure was 71.1 for angle M. Now what we need to do is figure out what this angle is. And remember from the video, the way we got that, since these are congruent angles inside this isosceles triangle, we do 180 minus 71.1 to figure out what angle M is for this version of the answer. And if you type that in, I'm getting 108.9 for that angle. And that is the new angle M, 108.9. Then we go ahead and do our calculations based on that angle for these other measurements. So we still need angle C, right? This is angle M, angle C. And we still need side C. Angle C, we can just get by doing the subtraction on these angles. We're going to do 180 minus 108.9 minus 58, which actually equals 13.1 degrees. So angle M we get by remembering that there's an ambiguous case. The second case, you use 180 minus the M that you found in the last problem. Then we finish this off by getting angle C using subtraction. And for the other angle C, we're going to have to use the law of sines one more time. So go back to sine 58 over 26 equals, and then we'll do sine of 13.1, our new angle, over side C. And so side C is going to be the answer to 26 times sine of 13.1 divided by sine of 58. Again, we're going to use our calculator to crank that out, and we'll see what we get. And when I typed that out, I came up with about 6.94. We're going to round that off to 6.9 because it says round to the nearest tenth. So our triangle this time, the angles are 58, 108.9, and 13.1, and the sides are 26, 29, and 6.9. Both of those, the angle triangle from the last slide and the triangle from this slide, those are solutions to number 19. A lot of work when there are two solutions, so we don't want to do too many like this, but I want you to be aware that this can happen, and this is how you solve for those problems. And if you made it through the video, you got a couple of free answers here. So I hope this helped clear up any confusion you might have. I think this strategy where we make up these new letters forces us to pay attention to which side is opposite and which side is adjacent, and then helps us determine what we need to figure out to solve the rest of the triangle. So give this a shot. Don't panic. We can always work on it more tomorrow. Okay, good luck. Take care.